Hey everyone, today we're on Unit 7, Lesson 2, which is solving exponential equations. Basically, the definition of an exponential equation, sorry about that, is an equation where the exponent is the variable. Steps to solving an exponential equation. We're going to isolate the exponential expression, rewrite both sides of the equation as exponents with the same base, set the exponents equal to each other, and then solve the resulting equation. Okay. Basically, with these types of equations, you only need to check your answer if you're not sure your math is correct. Okay. And in order to solve these, you may have to use either the laws of exponents or the quadratic formula. So we're going to deal with this. Now, this is a review topic. You've already done these last year in Algebra 2, so these should seem familiar. If we want to solve the equation for x, so I have 3 raised to the x plus 1 equals 81. Okay, notice our variable is in the exponent. So what we can do is, if you think about this number 3, that's the smallest base that you can have on that side of the equation. But on the other side, you want to think, how could you rewrite 81 as a power of 3, right? 3 raised to what power gives you 81? And that would be to the 4th power. Okay, so that's our rewrite both sides of the equation as an exponent with the same base. And now that we have the same base, since those two numbers in the base are equal to each other, we can just cancel them out. And we have x plus 1 equals 4. We solve this equation, and x equals 3. So you could go back in and you could check it if you want. You could do like a mental check, but it's really not that necessary, because if you did your math right, since the domain of an exponential function is all real numbers, you're never going to get an answer that's not in the domain. That's what's important to understand. Looking at example 2, okay, I have 5 on one side and 1/5 on the other. So I look at those two numbers, and 5 is basically in its most basic form there. So I can't do anything to that side. But how could I rewrite 1/5 as a power of 5? I'm going to take this and rewrite it to the -1 power. Remember, 1 over x to the m equals x to the -m. That's our laws of exponents coming to play. Continue on. We're going to cancel our common base. X plus 3 equals -1. Solve for x. And x is going to equal -4. And that's your answer. Once again, if you don't trust your math, you could go back in and check it, but it's okay if you just want to move on. 4 to the x squared equals 2 raised to the x. When I look at these numbers, I kind of am looking at both these numbers, and I see, are they powers of each other, right? So 2 to the x is good. I have to rewrite 4 as a power of 2. So I'm going to take the 4 and rewrite it as 2 squared. And I'm going to raise that to the x squared. And now I'm going to use my laws of exponents to rewrite this piece. When I raise a power to a power, I multiply. So 2 to the 2x squared equals 2 to the x. Once I get to this step, I can cancel my bases and set my powers equal to each other. And I have to solve this equation. So hopefully, this is a quadratic, so you know to get everything to one side. And I'm going to factor. And I'm going to set each factor equal to 0. And I have two solutions here. X is equal to 0 and x is equal to 1/2. So those would be my answers. Next one's a little bit tricky because of this square root sign. But essentially, if you look inside here, I have a 2 and I have a 2, so I have a common base. What I have to consider is, how can I rewrite that square root sign? And remember, another exponent law, r x to the p. So if I have the square root of 2, this is really the same as saying 2 raised to the 1/2 raised to the 2x plus 4 equals 2. When I raise a power to a power, I'm going to distribute, I'm going to multiply. So 1/2 times 2x is x, 1/2 times 4 is 2, equals 2. When I go to cancel my common bases now, be careful, because this 2 is really 2 to the first power. So I can cancel this out, and I have x plus 2 is equal to 1. Solve this equation, and x is equal to -1. Okay, so we have all sorts of funky situations that you're gonna see. Now I'm gonna do a couple with base e. Remember, base e is just a number. Okay. It's our base this time. So we have e and e. Okay. My bases are the same. I just have to rewrite that right side so it's in the numerator. E to the x plus 2 equals e to the -3rd. Now that I have common bases, just solve the resulting equation. Subtract 2, and x is equal to -5. Don't trust yourself, and let's just check this one just to show you, because it's weird seeing a number as a base. So let's say I plug -5 in for x. E to the -5 plus 2 equals 1 over e cubed. E to the -3 equals 1 over e cubed, and it works because e to the -3rd is really 1 over e cubed. So my solution here is x equals -5. In example 6, that is a typo. So let's cross off this example. And I have, let's rewrite e to the 4th, e to the 4th times e to the x equals 1 over e. Okay, so this is going to be our problem we're going to do instead. Now, when I look on that left side of the equation, I see an e and an e. So I've got to simplify this left side. I have to rewrite it as one base. Okay. What do I do when I multiply like bases? I add their powers. So this is e to the 4 plus x equals, and on the right side of the equation, I need to rewrite e as a power. So e to the -1. Cancel my bases. 4 plus x equals -1. Solve for x. And x is going to equal -5. Now we're getting a tiny bit trickier. I have e to the -x squared equals e to the x squared times e to the 1 over e cubed. Okay. Remember, we have to get each side with one base raised to some power. The left side is good. The left side is already set up. I've got to deal with the right side. So e to the x squared, when I multiply, when I raise a power to a power, I'm going to multiply the powers. And I'm going to take and I'm going to rewrite 1 over e cubed as e to the -3rd. Now when I multiply like bases, I can write that as a single base and add the powers. So my equation then that I'm going to ultimately solve to get the solutions to the original problem, cancel my like bases, x squared equals 2x minus 3. I have a quadratic, so I want to get everything to one side. I'm just going to add that x squared over. X squared plus 2x minus 3 is going to equal 0. And now I can factor this to solve it. Plus 3 minus 1. I have two solutions, negative 3, and x is going to equal 1. Okay. Okay, that one's a lot of work. And remember, when you get down here, this is math you're expected to know. So you might wind up getting things that you might not be able to factor, and that's where you would use the quadratic formula to get your solutions. And in this last example here, I have 9 raised to the 2x times 27 raised to the x squared equals 1/3. Now think of those numbers, 9, 27, and on the other side, I see a 3. So I have to think about what number, what base do they all have in common? And that would be 3. You want to go down to the lowest base. So I need to rewrite each one. When I go to rewrite 9 as a power of 3, it's 3 squared. But I'm still raising it to the 2x. Times 27 is 3 cubed. And I'm still raising that to the x squared. And 1 over 3 is 3 to the negative 1. 3 to the 4x times 3 to the 3x squared equals 3 to the negative 1. Multiply like bases, add your powers. I'm just putting them in standard form because I'm seeing a quadratic up there. Cancel, set them equal to each other. And since we have a quadratic, right, since I have x squared plus 4x, I'm going to be taking everything, moving it to one side. And now I have to factor this or use the quadratic formula, whichever you prefer. I prefer factoring it. This is a tricky trinomial, so I'm going to use the method I like to use. Remember, it's the rainbow or the bridge. It's a little cheat. 2 factors that multiply to 3 combine to give me 4. I put in a factor of 3. I have to divide that away. When I set each of these factors equal to 0, I get my 2 solutions, again, because it was a quadratic. Okay. You often find you're going to get 2 answers. X equals negative 1 and x equals negative 1/3. All right, so those are equations that you're expected to know already, and we're just doing them again this year so you don't forget how to solve each of those different situations. Now let's look at something a little bit different. We're going to solve equations that are what we call quadratic in nature. Okay, so I'm going to look at a problem first and then kind of help you see what I mean by quadratic in nature. When we look at this problem to solve, 4 raised to the x minus 2 raised to the x minus 12 equals 0. Well, in each of the other situations, we could rewrite it by using exponent laws. But here, we don't have an exponent law that's going to apply because I have 3 terms and I have an operation in between those 3 terms that's not multiplication. So I can't add my powers. I can't do anything like that. So what I'm going to try to do first is, well, I see I have this base 2 here. So instead, what I would do is I would take 4 and rewrite it as a power of 2. And when I have 2 squared raised to the x power, when I raise a power to a power, remember, it's the same as multiplying. Now, that doesn't necessarily help me, but this step might. Instead of writing 2 raised to the 2x, now let's apply those laws of exponents again and rewrite this power. And instead of writing 2 raised to the 2x, 2 to the x squared minus 2 to the x minus 12 equals 0. Now, hopefully, with that little manipulation there, and it's all using properties, but with that little manipulation, can you see the quadratic in nature? Something squared, something, and a constant. Something squared, something, and a constant. So it's that base being squared. This is our what I would mean by quadratic in nature. And in these types of examples, so basically we want to kind of consider rewriting with exponent laws. And if you see a quadratic, what we're going to do is we're going to use what we call U substitution. Okay, and anytime in math that we use U substitution, it just means we're going to, on the side, say, let U equal 2 to the x power. And I'm going to rewrite this expression right here in terms of U. U squared minus U minus 12. Set that equal to 0. Now what I'm going to do is I'm going to factor this and solve for U. So instead of putting an x in the first place, I'm going to put a U. What two numbers multiply to negative 12 and combine to give me negative 1? Minus 4 and plus 3. I'm going to just come up here so I have a little more room to explain. Set each factor equal to 0. And I get U is equal to negative 4 and U is equal to negative 3. But we're not really solving for U. Remember, U is equal 2 to the x. So once I get that to that step, I'm going to go back in and replace U, 2 to the x equals negative 4, and 2 to the x equals negative 3. And this is not the best example because think about it. In our exponential function, in its most basic form, can I ever get a negative number as a solution? No. An exponential can never be negative, right? So there's no solution here, and there's no solution there. Oh, no, I made a mistake. Let's take that back. My bad. I'm very sorry about this. Take a deep breath. This only applies to this side when I have an exponential function equal to a negative number. There, my answer is positive. I'm so sorry. So really, I'm doing 2 raised to the x equals 4. Okay. And now with this problem, you can use common sense, but if the numbers are a little complicated, what do you notice here? I can rewrite each side with a common base. And then my solution is right there in front of me. And again, I apologize about that. Moving on. An example 2. 2 times 49 raised to the x power plus 11 times 7 raised to the x power plus 5 equals 0. You can almost see the quadratic there. But let's take it step by step. My base is going to be 7. So I want to rewrite 49 as a power of 7. Now, you could take the 2 steps to do this, or you could realize you could just flip those 2. 2, 7 raised to the x power squared. No matter which way you apply your exponent law, you're always going to get 2x. My u is going to be 7 raised to the x power. Rewriting this in terms of u, I get 2u squared plus 11u plus 5 equals 0. I'm going to use my little bridge method. Two numbers that multiply to 10 combine to give me 11. So that is 10 and that is 1. 2u plus 10 equals 0. 2u plus 1 equals 0. U equals -5. Oops, made another mistake. I have dogs barking outside my window. I'm outside my door. I'm sorry. I'm just getting distracted. We're going to get rid of that. We're going to go back to we're going to get rid of that. Okay. We're going to go back to where I started here. And I apologize. 2u plus 10 plus 1. That was right, but I should have divided by 2 before I moved on. U plus 5 and 2u plus 1. Now we're good to go. So u equals -5 and u equals -1/2. But remember, u equals 7 raised to the x power. So essentially, we've got to replace this. And the nice thing about these problems is when we get down to this step here, if you see a negative, there's no solution. You can automatically, you don't even have to do anything else, because an exponential function can never equal a negative number. Okay. So unfortunately, after all that work, you still got no answer, but that's okay. That is an answer. Okay. And that's what we have for today. Thank you for following along, and we'll see you soon.